Welcome everyone. Today we're going to talk about the reciprocal trig ratios, sometimes also referred to as the secondary trig ratios. So in grade 10 and so far in grade 11, we have learned about sine, cosine, and tangent. They also have related reciprocal trig ratios, which are essentially the reciprocal of their specific primary trigonometric ratio. So sine, cosine, and tan are referred to the primary trig ratios. So cosecant, secant, and cotangent are their reciprocal ratios. They also have short forms, just like sine, cosine, and tangent have. So cosecant has a short form of CSC, and this will be theta. And this is equal to the reciprocal of sine. So what this means is if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Okay, and then the short form for secant is SEC. It is the reciprocal of cosine, meaning that instead of adjacent over hypotenuse, secant is hypotenuse over adjacent. And lastly, we have cotangent. Short form is COT. And it is the reciprocal of tangent, meaning that if tangent is opposite over adjacent, cotangent is adjacent over opposite. So we don't really need to memorize the ratios, as in secant is hypotenuse over opposite. All we need to know is that sine and cosecant are reciprocals of one another, cosine and secant, and tangent and cotangent are reciprocals. And then if you know SOHCAHTOA, you can set up the ratios for cosecant, secant, and cotangent. Okay, so we're going to find the exact values for the special angles 0, 30, 45, 60, and 90 using the reciprocal trig ratios. So for 30, 45, and 60, we are simply going to use the special triangles. So I'm going to draw the special triangles above, just as a little reminder for us. And I'm going to quickly enter in the ratios for sine, cosine, and tangent of 30, 45, and 60 because we've already reviewed these in previous lessons. So here's our 45, 45, 90 triangle. And here is our 30, 60, 90 triangle. Okay, so just quickly here, entering in sine, cosine, and tan of 45. And then sine, cosine, and tan of 30. Oops. And sine, cosine, and tan of 60. Okay, so remember that sine is the reciprocal of cosecant and vice versa. So if I take all of these values for sine in this first column here, so 30, 45, and 60, then really all that I want to do for cosecant is do each of their reciprocals, and that will give me the ratio for cosecant 30, cosecant 45, and cosecant 60. I also know by looking at the triangle, for instance, if sine of 30 is opposite over hypotenuse, then cosecant of 30 is going to be hypotenuse over opposite. So you can kind of do it that way as well. Okay, but I think it's just easy to kind of look at the primary trig ratio and do the reciprocal to get the secondary trig ratio. Okay, so for each of these in the first column here, I'm just doing their reciprocals. And then we've got the answers for cosecant 30, 45, and 60. Okay, similarly, I know that secant is the reciprocal of cosine. So I'm going to take all of these values for cosine in this third column here, and I'm going to do their reciprocals, and I'll have the answers for secant. So reciprocal just means we're flipping the fraction. Okay, and then same thing with the last column here. Tan and cotangent are reciprocals, so I'm going to take each of these values and do the reciprocals. So reciprocal of 1 over root 3 is root 3 over 1. That simplifies to root 3. Reciprocal of 1 is 1. And reciprocal of root 3 or root 3 over 1 is 1 over root 3. And that gives me all the values for cotangent of those special angles. Okay, now 0 and 90. This also goes for 180, 270, and 360 as well. We can kind of use this method that I'm going to show you. Now, of course, we can use our calculator for this, but I can also use this idea of what we talked about in our previous lesson, which is setting up the trig ratios in terms of x, y, and r. So I'm just going to remind you about that here. I can set up any circle where I have a point xy on the outside of that circle, and I have a radius leading up to that point. So this is our x distance, our y distance, and this is the theta that we need to rotate to get this terminal arm of the radius. So we talked about how the sine of theta is opposite over hypotenuse, or in this case, y over r. Cos of theta is equal to x over r, and tan of theta was equal to y over x. Okay, similarly, that means that the reciprocal ratios, cosecant theta is equal to r over y. Secant theta would be equal to r over x, and cotangent theta would be equal to x over y. Now, we're going to use something that is called the unit circle, and the unit circle is a special circle because it has a radius equal to 1. So when we go to find the sine or any of the trig ratios of 0, 90, 270, 180, or 360, these are special values because they're right on these specific lines as far as rotation around the around this unit circle. Okay, so every other point creates a triangle, but if I have a point, let's say at 90, this is actually just a line, and I can't really create a right angled triangle with the closest x-axis. So I'm just going to erase this so we can kind of visually see what we want to do here. So here's the idea. I want to use this idea of the unit circle still. So we know the radius is equal to 1. That was a bad circle. Let's try one more time. Good enough. And I'm going to start with 0 because we're trying to find sine, cosine, and tan and their reciprocals when we're at the 0 degree mark. Now let's think about this for a second. If I'm measuring from here to here and the radius of this circle is equal to 1, if I think about this in terms of an xy coordinate, if I go 1 unit over on the right on the x-axis, this is actually the point where x is equal to 1 and y is equal to 0. This is the point 1, 0. Okay, and I know that because this measurement right here is the radius of the circle, and I know the radius of the circle is 1 unit. So if I go 1 unit over on the x-axis, so if you think about your x and y axis in terms of little ticks here, if I go over 1 unit on the x-axis, I know this point is 1, 0. Okay, that's the point that I've labeled here. Okay, I also know that sine is equal to y over r. So if radius is equal to 0, or radius is equal to 1, and y at this point is equal to 0, I should be able to set up the sine of 0. So let's just do that over here. Sine of 0 degrees is equal to y over r. Y in this location is 0, and the radius of the circle is 1. So any radius that I plug in here is always going to be equal to 1. And I know 0 over 1 is actually just equal to 0. So the sine of 0 is 0. You can also check this in your calculator. So I want you to grab your calculator. You're going to input sine of 0, and you should get out 0. So this is kind of the reasoning why sine is actually equal to 0. Okay, so you should be able to do this without a calculator, but you can certainly check with your calculator if needed. And now the reciprocal. So the interesting thing about some of the reciprocals when we're dealing with 0, 90, 180, 270, and 360 is that some of the reciprocals can potentially be undefined. So just as a little legend here, I'm going to use U just to represent undefined for this table. So let's think about this. If I do the reciprocal of 0 over 1, I get 1 over 0. So I'm just talking about doing cosecant of 0 here. Now, if I get 1 over 0, we know anything divided by 0 is, think about it for a second, is undefined, right? I can't do 1 divided by 0. That's an undefined value. So when I do the reciprocal of 0, I'm going to get an undefined value. So we're going to actually put that in for cosecant here. That's actually undefined. Okay, let's set up the rest, the cosine of 0 and the tan of 0. So cosine of 0 is x over r at the 0 degree location. Okay, that's why we're at this location, is because we're doing 0 degrees. And x at this location is 1, and I know the radius is 1. So we get 1 over 1, which equals 1. Okay, check it on your calculator. Input cos of 0 and see if you get 1. Okay, you should find that you do. And then the reciprocal of that is, the reciprocal of 1 over 1 is 1. So the secant of 0 is also 1. Okay, and then let's look at the tan of 0. This is going to be, oh, I accidentally erased this. The tan of 0 is going to be y over x. And y in this location, again, is 0. And x in this location is 1. So we actually just get 0 for the tan of 0. Okay, and that means that it's reciprocal cotangent. When we do cotangent of 0, we will get an undefined number. Okay, so if you enter into your calculator tan of 0, you'll find that you get out 0 from that. Okay, now let's look at 90 degrees. Okay, so I'm going to move the location of my arm here to the 90 degree location, which is this location here. And we need to think about, if I go 1 unit up on the y-axis, we need to think about what point that will be using an xy coordinate. So at this point, x equals 0. And if I go up 1 unit on the y-axis, then y must equal 1. Okay, so let's think about sine of 90, cos of 90, and tan of 90 here. Okay, same rules apply. We're using these right here, and the radius is equal to 1. Okay, so if sine is equal to y over r, y in this location is 1, and the radius is always 1. So we actually get 1 for the sine of 90. And its reciprocal is going to be, not undefined, sorry, is going to be 1. Reciprocal of 1 is 1. Okay, and then let's think about cos of 90. This is x over r. X in this location is 0. And radius is, of course, 1 because this is the unit circle. So this will be 0 over 1, which gives us 0. Okay, and we know the reciprocal of 0 is undefined. Okay, and then finally for tangent, tan of 90, this is going to be, we're looking for y over x at this location. And this is going to be, y is 1 at this location, and x is 0. So this will be 1 over 0. And we know 1 over 0, that's actually not equal to 0. That's undefined. So tan at this location is actually undefined. If you enter in the tan of 90 into your calculator, you're actually going to get a math error. And that's because tan actually has an asymptote at this location. When we think about like sorry, I'm getting into some of our next unit stuff, but when we think about actually graphing this as a function, it means there's an asymptote, a vertical asymptote there. It also means that I can't do the tan of 90, so it's not possible. So if we think about the reciprocal for cotangent, if tan is 1 over 0, then cotangent is 0 over 1, and that means we get 0 for cotangent. Okay, now you guys are going to complete a couple other ones throughout the rest of your homework. I don't think we do any more in this lesson. But if you happen to need to do sine, cos, tan, or any of the reciprocals of 180, the point here would be -1, 0, because we're going to the left on the x-axis. And then if you're doing 270, your point will be 0, -1, because we're going down 1 unit on the y-axis. And then again, if you're doing 360, it's actually going to be the same point as 0 because these are in the same location. So you use the point 1, 0. So these are basically the points that you can use if you're doing sine, cosine, or tan, or the reciprocals of 0, 90, 180, 270, or 360. So there were a few questions on yesterday's worksheet which ask you to find either sine, cos, or tan, or the reciprocals of those specific values on the lines that divide all the quadrants. And I would encourage you to take a look at some of those and give those a try. Okay, so moving on to kind of like some of the stuff that we've done in previous lessons, but with the reciprocal ratios. We're going to determine the exact value of all 6 trig ratios for angle A. So if we consider this to be our reference angle, this will be adjacent, opposite, and hypotenuse. So if you can set up the primary trig ratios, sine A, cos A, tan A, just as you usually do with SOHCAHTOA, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Then to find the trig ratios that are reciprocal ratios, all we need to remember is which trig ratios are reciprocals of which primary trig ratios, and we'll just flip the fraction. So cosecant is the reciprocal of sine, so that means cosecant of angle A is 13 over 12. Okay, similarly, secant is the reciprocal of cosine, so secant must be equal to 13 over 5. And cotangent is the reciprocal of tangent, so that must be equal to 5 over 12. So this is our solution for this question. Okay, also take a look at the instructions for the question. When we say exact value, that means no decimals. So you're going to leave this in fraction or radical form if necessary. Because there's no radicals in any of these side ratios, we're just leaving the ratio as an exact fraction value. That's why I didn't actually calculate any of these. Okay, I also don't need to calculate angle A in order to set up all these ratios. All I need to know are all 3 side measurements. Sorry. Okay. So we're going to also expand on some previous work that we've done in finding 2 angles that have specific ratios, but this time with reciprocal ratios. So we're going to use the cast rule in this, and we're also going to need to know which primary trig ratios are the reciprocals of the secondary or reciprocal ratios. So cosecant, if cosecant is 8 over, remember, any denominator of a regular number is equal to 1, that means that sine, its reciprocal, is actually equal to 1 over 8. Okay, these are reciprocals of one another. So the only difference between this and what we have previously done in order to find angles is that I actually don't have cosecant, secant, and cotangent in my calculator. I only have sine, cosine, and tangent stored in my calculator, and their inverse notation, sine inverse. So this little sine inverse, this is actually different than cosecant. So that's actually really important to know, is that cosecant is a reciprocal, whereas sine inverse is an inverse function, okay? So those are 2 totally different things. But I can use sine inverse now that I've placed my reciprocal ratio into a primary ratio. And I'm also going to use the cast rule. So thinking about what we did in our previous lessons, if we use the cast rule here, if I'm looking for two angles of theta that will give me a positive ratio, I know that sine is positive in two quadrants. Let's think about those quadrants for a second. See if you can circle them on your lesson. Okay, sine is positive in the all quadrant and in its own quadrant. So I should expect to get two ratios. We'll call this theta 1 and theta 2. I should expect to get two angles here that will give me the same ratio of positive 1/8. So how do I find these angles? Well, if you think back to our previous lesson, we found these angles by doing sine inverse of the value. So if we enter this into our calculator, sine inverse of 1/8, make sure you're in degree mode, we're going to get a first angle of 7.18. So let's just say we're going to round this to 1 decimal place. We'll do 7.2. This is the angle in the first quadrant. It's between 0 and 90. So that must be the measurement of this. And then I also know that the reference angle, or the angle between theta 2 and the 180 line, will also be the same as that first reference angle there. Okay, so if I want now this rotation, I'm simply going to take 180 and subtract 7.2. Okay, this gives us 172.8, and that will be the measurement of the second angle. Okay, you're going to do a little check in your calculator. The fraction 1.8 is equal to 0.125. So if I check the sine of 7.2 degrees and the sine of 172.8, it should actually give me back out this value, which is 0.125. So let's just check it. It's going to be off a little bit because we rounded, but this is approximately equal to 0.12533. Oops. 0.12533 and so on. So that's close enough for me. And it's positive. That's also an important piece of the puzzle. If I find the angle in the wrong quadrant, it will still give me the same ratio, but it will be negative. Okay, so just due to rounding, that's slightly off a little bit, but I think those are close enough for me to say that we've gotten the correct answers. Okay, let's take a look at part B here. Just going to make that a little bit smaller. Okay, part B. So let's think about what secant is the reciprocal of. If secant theta equals 5/2, this means that its related primary trig ratio, which is cosine, is equal to 2/5. I'm not going to use this anymore. Now that I have this information, that's really all I need to continue solving the question. But this technically is the original question that I'm trying to solve. Where is secant equal to 2/5? For what angles? Okay, so we're going to use the cast rule again. And this is equal to a positive ratio. So the cosine of some angle, or maybe multiple angles between 0 and 360, will give me a positive ratio. So I want you to think about what quadrants cosine is positive in. Okay, use the cast rule. See if you can circle them. Okay, if you said all and cosine, you're correct. Okay, so the first angle that we'll get is the angle in the all quadrant, and then we will find the second angle by using the reference angle inside here. Okay, so use your calculator. We're going to do cos inverse of 2/5. And let's round to 1 decimal place here. This is going to be 66.4 degrees. Okay, that's actually the angle measurement in the first quadrant. And that's also going to be the reference angle. So we're always looking for the angle between 0 and 90 degrees to be our reference. Okay, remember this is the 0, 360 line. This is 90, 180, and 270. Okay, so this is actually theta 1 here. This is one of our possible answers. And our next answer is going to be this rotation here. So I know that that blue rotation is actually close to a full rotation, but it's less 66.4 than 360. So our theta 2 can actually be calculated if I calculate a full rotation of 360, but less 66.4 degrees of that. So you can put that into your calculator, and we should get 293.6 for our second theta. Okay, this should be an angle, if I've calculated it correctly, that falls between 270 and 360, and this is, so that makes sense. Okay, we'll also do a quick little check of our work here by calculating the cosine of 66.4 and the cosine of 293.6. Sorry about that. So if we plug it in, because we've rounded a little bit, it will be slightly off, but we should get 2/5. So this is about equal to 0.4. And that's actually equal to 2/5 if we calculate 2/5 as a decimal. So that's good enough for me. And this one will also be approximately equal to 0.4 as well. So that is good. I'm also really paying attention here just to make sure that I have done this correctly. I'm really paying attention to whether this is negative or positive as well, because if I choose the wrong quadrant or I calculate in the wrong quadrant, I'm still going to get approximately 2.5 or 2/5 or 0.4, but some of them will be positive in some quadrants and some of them will be negative. So if I choose like sine or tan accidentally, I'll still get 0.4 for my answer, but it will be negative. I'm looking for where I have positive 2/5. So just make sure you're getting the correct sign in front of your ratio as well as the correct ratio value. Okay, and one other thing that I should also reiterate here is that I'm never using 270 or 90 to calculate my rotations. I actually always calculate rotations in these three quadrants, sine, cosine, and tan, using the 180 or 360 lines. Okay, so if you're using 90 or 270 to make a calculation, you're not doing it correctly. Okay, let's try another one. So cotangent is equal to 5/16. This means that tangent is equal to 16/5. And this is a positive value. So I'm interested in where tan is going to equal a positive ratio. So let's think about the quadrants based on the CASP rule where tan is going to be positive. Okay, see if you can circle them. If you said all and tan, you would be correct. So I have an angle here and an angle here, where the angle between the horizontals are equal. So those opposite angles there are going to be equal. We'll call that theta 1 and theta 2. The next thing that I'm going to do in order to find theta is do the tan inverse of my ratio. So use your calculator. Again, you need to be in degree mode in order for this to be giving you the proper answers. And let's round to one decimal place here. You're going to get 72.6 degrees. That's this measurement in here. And it's also this little slice in here as well. Okay, so I've got theta 1. Now I want this rotation to theta 2. And that's basically going to be from 0 to 180. Plus an extra 72.6. So again, I'm not using 270 or 90 in order to do this calculation. I'm taking 180, so the rotation from 0 to 180, and it's going past 180 by 72.6 degrees. So we're actually just going to add that right to 180. And again, rounding to one decimal place there, we get 252.6 degrees. And this should be a value between 180 and 270 if I've done this correctly. Okay, we're going to do a little check here. Plug these into your calculator, tan of 72.6. We should get, if I calculate 16/5, I get 3.2. So I should get something relatively close to 3.2, when I sub these in for tangent in my calculator. Okay, so I'm going to do it right now along with you guys. I got 3.19. So that's close enough to 3.2 for me to be happy with that answer. And it's also positive. That's what I'm looking for, positive 16/5. So I'm making sure that I'm getting the correct signs as well as the correct ratio. Okay, and that one is close enough for me as well. Okay, if you leave a few more decimals, you'll get an even closer answer once you plug back in to check. Okay, and last question for today, determine two angles between 0 and 360 that have a cosecant of -2. So this is basically what we did above, just asked in a bit of a different way. So if I know cosecant is equal to -2, think of this as -2/1. We know any regular number just has a denominator of 1. And that means that sine of theta is actually equal to -1/2. So I am looking for two quadrants where sine is going to be negative this time. Okay, so this is a negative number. So let's think about the cast rule, and I want you to circle the two quadrants where sine of an angle will be negative. Okay, if you said tan and cosine, you're correct. Okay, so these are going to have equal reference angles inside here, so it's always the horizontal that we're using to determine those equal angles. Okay, so let's do the sine inverse of -1/2. Okay, I got a negative answer, -30 degrees. This is not between 0 and 360. This is less than 0. So this actually doesn't work as a proper answer, but we know we can make any negative angle positive by simply adding a rotation of 360 to it. So we learned about this in the coterminal angles unit, or lesson rather. And if I add 360, I get 330 degrees. That's actually giving me the value of theta 2. That's the value in between 270 and 360. So it actually was telling me that this was -30, but this rotation, if I go counterclockwise, is 330. Okay, that means this little reference angle slice inside here is actually just simply 30 degrees. Okay, so usually if I get a negative angle, that's really just telling me like its positive version is my reference angle, and I can work from that. Okay, so this is our theta 2. And in order to find theta 1, I'm going to take my rotation of 180 degrees here, and I'm going to add 30 degrees to that, because I'm 30 degrees past 180. And that will give me 210. Okay, we're going to do a little check on our calculators. Enter in sine of 210. And sine of 330. If we've done this correctly, then I will get exactly -0.5 for both of these. Okay, so I'm getting -0.5, which is -1/2, and sine of 330, I'm also getting -0.5.